developers. I'm really excited about today's live stream. I'm here with Deepak and Sudeep from Inco. We're gonna do a bit of vibe coding and learn about Inco and confidentiality along the way. Hey guys.
Hey, yeah, I'm Sudeep. So today
Hey,
we'll be like just walking you through like how you can use AI agents and how friendly our documentation is for you to build. And we're gonna explore like probably understand how you can have a multi-party privacy where you have multiple people participating, and you have hidden states that can be shared between them. So that's what we'll be exploring today, and we'll
Very
make
cool.
sure we're using AI agents. It's either going to be Claude or Cursor. I'm very familiar with Claude, so I'll be walking you through how to set up with that. And most of the program is going to be written by the agents, so expect like some issues. But yeah, we'll debug it along the way. And
Cool.
Deepak will be walking us through how we'll build the front end and stuff. So I'll be doing the programs. We'll understand the logic and then start. We'll understand how do we implement it on a client side. So yeah, happy to
Nice.
be here.
That's really exciting. I guess I can probably jump in. We've got people watching us now, so you want to share your screen?
I'll yeah, I'll probably walk you through like the concepts first, and then just start working with those concepts after that.
Perfect. That sounds great.
Yeah, we have introduced Inco before. So the current blockchain stack is such that everything on it is in plain text, and that's the only way you can validate the data that is there in the blockchain. That is how your decentralization assumptions are derived. What Inco does is you will be able to do encrypted computation on top of these blockchains, and this will be basically offloaded to a co-processor where your encrypted operations are done and committed back to the blockchain. No. So you must have like understood that with the recent growth of Zcash and other protocols, there are multiple platforms that can be built on top of it. Be it dark pools, be it blind auctions, payrolls, and in gaming, we've seen that multiple people have built casinos as well as blackjack and few other games on top of blockchains which require privacy. So the way they used to do it is they used to compute off chain and provide ZK proofs to it. So you will be able to have these logic completely on chain. So yeah, how does Inco provide privacy? So we leverage TEs for confidential computes. So users create encrypted intents and they submit it on chain. So your ciphertexts are emitted as events. The TEs capture them. That is why we call it symbolic execution. And if you want to do an encrypted addition, you send into ciphertext and you say, "Hey, I want to add these two." So and the TE executes it on behalf of you. So this is how you're able to do confidential compute, be it any type of operation. And one important thing that this introduces is granular viewability. So what I mean by that is, let's say there's a transaction between Bob and Alice. In the general approach or the commitment approach, you will have to share a viewing case, which would mean that you will be giving them forward observability, so they will be able to see what transactions you have made in the past as well as in the future. But with TEs, we have something called access control list, where you can allow only a specific ciphertext or only a specific state change to a person. So what this does is you can have delegatees, you can have auditors, you can have other government entities being able to see certain transactions that are relevant to them, and they'll not be able to basically see things that do not belong to them. So it gives you granular access control. Now, coming to how you build this programs, right? Familiar with Anchor, you're very familiar with Rust programs. So we made sure that you're able to introduce encrypted using your like natural programming language. You do not have to write in different code. And hey, these are all opcodes that you know, right? Like addition, subtraction, and multiplication. So it's as easy as writing your plain text programs on chain. So yeah, I will be going through some of the examples. Uh, One such as confidential SPL token. So we introduced this token program to work with encrypted types. You must be aware of the confidential token extension, which uses linear homomorphic encryption and multiple ciphertexts. The difference between that and ours is you will be able to work with a single ciphertext, and the transfers are stateful. So you will be able to view your balance, allow others to view your balance without a lot of key communication or key sharing being required. And as you can see here, you want to do a transfer, right? You want to check if Bob has sufficient transfer before his check. Hey, is it greater than the amount that he's trying to transfer? If then, let's transfer it. So that is the select operation. So this allows you to do logical branching. I will be explaining this as and when we look into the code. So basically, it allows you to two conditions based on a boolean. So so that is one great example. And private voting. So the votes that you like cast are hidden. Your identity is still visible. It's just that the weight of your votes as well as the votes you're doing are hidden. And yeah, one nice thing is we have something called Lightning Rod, which allows you to work with existing stacks. That is Anchor. You'll be able to interface with your Phantom wallet as well as build on top of Rust native programming language. So yeah, the documentation. So who is looking at it, you can just follow it here. And now I'll be just walking you through, like, since it's about like vibe coding, right? We will be dealing with agents. So I will be teaching how you can set up MCPs so that you can just query our docs without having to like copy the documentation over and over, and your agent has full context about how Inco's encryption stack works. So yeah, let's dive right into it.
Do you guys have a, sorry, just to interrupt, do you have a skill as well?
No, it's work in progress, but we will be introducing
Cool.
skills soon. Yeah.
Nice. Yeah, I think people seem to be
Awesome.
moving over from MCP to skills for a lot of dev stuff.
Yeah. Let me just set up my desktop and I'll be sharing screen.
We've got some G Incos in the chat. G Inco, am I saying that right?
Are you able to see my um, screen?
Yes.
Awesome.
Wait. Yeah, we can just see the restream though.
You're not able to see cursor?
No, I think you're sharing the wrong tab.
I see.
Cursor, is that your go-to AI coding
Uh,
platform?
it is. So I use
Nice.
like a combination of Cloud Code as well as Cursor. So if it's gonna be like, hey, it's small edits and it doesn't require a lot of logic, I just go with like Cursor, so it's able to make edits faster, and I'm able to choose between the models that I want here. But if I want to do something like I want like a logic to be implemented, Cloud Code is the best way to go.
Yeah.
Yeah.
Yeah, I agree with that. I kind of build stuff within Claude Code, and then if I need to edit little things, I open it up in Cursor and do like more
Yeah.
specific, like edit these things. That's my flow
Yeah.
anyway.
Like the extension mode rather than using it in the terminal. So so you have extension over here.
Oh yeah. Yeah, that was the first way I was using
Yeah,
it. I love it in the terminal though.
I agree. I agree. Yeah. So today we're exploring like how we can have like a multiplayer setup with encrypted states, right? So I will take a very simple example today. It's going to be like rock paper scissors. It's a simple game. If we try something more complex, the chances of Claude hallucinating and I'm going to sit here the whole day trying to debug what it's done. So yeah. Yeah, so so yeah, the concept here is that like, hey, the second player should not know what the first player's input is, right? So the first player is going to be like, hey, it's going to be an encrypted input, and once the second player joins and puts his input, we'll be able to compare and we'll know the winner. It's as simple as that. So before I start, uh, the way you add MCPs to the plot, you can go to the cursor settings. Is this visible? This must be visible now.
Yeah.
Yeah. So you will there's something called tools and MCP. So you will be able to add MCP servers here. Ours is exactly our URL is basically docs.inco.org/MCP. So you'll be able to query what is in the docs, and the agent will be able to get sufficient context. I'll just give a small example. Um, so it reads the documentation from Inco, and yeah, so you'll see here this is the MCP tool that just ran. So it'll be able to get all the context from the docs. So alternative to having this MCP is you can just go to our documentation, um, and you can copy them as LLM friendly text. So I think every Modify documentation has it. So you'll be able to copy this page as a markdown file. So you can either use the MCP or do this. So you'll be able to see, you'll see that like, hey, I'll give an example of how to do it, how to set up the repository, how to configure, basically deploy something. So this for Cloud Code, you'll be able to check whether it's installed or not by just /MCP. So it tells which all MCPs are connected. You'll see that like Inco MCP is connected here as well. The biggest advantage of this is when you're using older models, they will be indexing a product which is like slightly older. So it will be referencing code, referencing testnet configurations that no longer exist, which would lead to like developers not like building the right thing. So these tools come into play very well. So yeah, what is our prompt going to be? Yeah, on
Maybe before we just dive into this, we should install some of the tools for Inco. Or I guess, I mean, it can do it by itself, but then you have to give it access to doing that,
exactly.
right?
We're going to ask the agent to do it by itself.
Okay, cool.
Yeah, but I will let you know what we're installing as and
Yeah,
when it
that
does it.
sounds good.
So yeah, for demonstration purposes, we'll have both two players and a single player. So we have something called encrypted random, which allows you to have an encrypted number. So the only reason I'm doing it is like it will be easy for testing purposes, and we'll be able to test even the multiplayer setup. So encrypted inputs, and test it. We might
What
also
is
want
what
to.
is Lightning?
So lightning,
Like,
so lightning is our EE stack. So why is it called lightning? Because it is fast. So the latency between you sending your encrypted intents, basically your EAD or E subtract on chain, to you getting the result from the stateful DEE is very fast, which is why we call it
mm,
lightning. And lightning rod allows you to capture lightning, right? So lightning rod is something that we took from Minecraft, which are like, yeah, I mean like, so yeah, it allows you to capture lightning. So basically, this is a DDK, a developer kit, which allows you to build on top of.
cool.
We want to allow users to view each other's inputs on second players.
Is there so the Inco SDK is this is a TypeScript SDK or Rust? Or what language
Uh,
are we going to be building this in?
right. The client side SDK where they're going to integrate with like front end, right? It's a JS SDK,
Yeah.
and For the programs, it's a Angular Rust, right?
Cool.
Yeah. So yeah. So yeah, as you can see,
Do we
it's
need to
gonna ask.
specify that it's Solana?
Um, I think given how smart this is, you understand it's. Yeah, I think we need to put it as Solana.
Oh, Solana. Nice.
Yeah, it is actually a reference for the SVM documentation. So yeah,
Cool.
while this thing does its job,
Oop.
it's a,
Studio, I think you're losing internet.
yeah, it's a
Oh, you
it's
seem
a,
to be back.
yeah,
Okay, cool.
it's a better, yeah. Yeah, things that you need to have before you can start working with Inco. That is the executor program or the Rust crate, which allows you to create your encrypted intents on chain and allows our keys to listen to it. And to create that, you will require a JS SDK. So that is Solana, Inco Solana SDK. You can install these separately, or you can just start off with our SPL token program, which allows you to work with this CSPL token program, or you can work with our private raffle, which is what I did in the previous stream. So you'll be able to create games. So Lightning Rod, let me just go to Lightning Rod. Yeah, so you'll have to clone Lightning Rod and install your dependencies, and you'll be able to start working with it. So yeah, that's what we expect this to do. See, it's setting up a new folder.
When you use the Cloud Code
Yeah.
extension in Cursor, can you do dangerously set permissions?
Yeah, you can. So which is why I set it up as like in such a way that you'll be able to. So here, right, there's something called edit automatically, plan mode,
Mm-hmm.
and ask before edits. So I'll be able to ask before edits before it starts making edits itself. Say like, hey, allow all edits for this session. So yeah,
Cool.
it's not like super dangerous. It's not like it's gonna start working with your private keys and stuff. But you should be safer with it.
Yeah. Should we scroll up and see what it's doing?
Yeah, let me just a second. Seem to have. Hmm,
What happened?
I do not know.
Was it working in the wrong directory or something?
Yeah, I was.
Whoops.
Anyway, I'll just continue from here.
Okay, cool.
I forgot what it was called. Yeah.
Why has it got Inco token?
So that is the lightning rod. So if you want, this is our
Hmm.
template that you can start working with, and then you just create another program with it.
Nice.
Yeah.
so fast. It's so crazy how much AI can do.
That's true. It's just weird that I lost all the history on it, though.
Yeah. It's kind of fun that it didn't go into planning mode first. Just YOLOing everything.
That's true.
Let's go into Inco token. Maybe we can talk through this
Yeah.
while AI is learning it as well.
Yeah. Yeah. To start off with developing, right? In a program, you will have to import types. So there are certain types that we allow and operations that we allow. That is EU 128 type, EU 128 type, and E Boolean type. And you can do multiple operations on top of it, like select, subtract, and operations that you want. One important operation is allowance. So allowance is how we deal with granular control. So remember when I told like you can reveal only certain information to certain entities. So what I do is every time you want to do an allowance, for example, let's probably just do transfer. So you want to allow both the sender as well as the recipients are. So you'll be like, hey, ciphertext, that is my newest destination balance to the recipient, and allow the sender's balance, new sender's balance to the sender. So this way, when they request to decrypt from off chain, we'll be able to see their balances. So it is important that we do allowances for every encrypted transfer that we do, encrypted operation that we do, and walk you through like how the transfer works. So in the natural, in the plain text flow, right, you will be first like, hey, this much amount is deducted from his account and added to the ATA of the recipient. So we will be also doing this similar flow, except we do not have reverts. You cannot revert in on encrypted types. The problem with that is if we allow reverts to happen on encrypted types, we'll be leaking information. People could just spam with an increment of one and check until after which the amounts start reverting, and they'll be like, hey, this is balance. So we don't want that. Um, yeah, we'll get back to that. So we have something called e-select. First, we check whether we get an e-boolean for comparison. So we check whether he has sufficient balance, which returns an e-boolean, and we use this condition to branch. So if he has sufficient balance, we're going to do the transfer that he's trying to do. Otherwise, we will do a zero transfer. So the total, the net state change is zero, and uh, so yeah, once based on this boolean, we will be adding that amount to the destination, and we'll be deducting that from the origin. So yeah, that is how like token transfers works. For mint is just like addition to it, and for just a second. Oh, yeah, for recipient we just add it, and for the sender we subtract. Yeah, now coming back to the game itself, let's see what it has written. So you'll see that it has done the imports that we require, equivalent checks, select, allow, and new event 128, and the types that we require, booleans and encrypted 128 types.
Maybe we can go to the
Uh,
chat and see what it said that it's doing, and then like compare it with the code. Could be
yeah.
cool. No, it's building it already, so
Oh yeah, it's already built.
nice.
So you create a game, you join the game, you reveal the result. It's done using equivalence check and select. So when you create a game, that's the first player. So he'll have the signer, the player one, and the player two can join later. And the first person's move, and move two is initially set to event 8 128 or 0. So this is because we will have to initialize encrypted types in the starting, so that when you reference it later, have a handle rather than an entire ciphertext. So we initialize it with zero value, and we have initialized the result with zero. Now, so yeah, there are three guesses that you can do. That is like zero, one, or two. I'm gonna check what it. So yeah, so zero
So
zero
what is
is
the logic for this? So a
yeah.
user
You can add
selects 0, 1, or
yeah
2. Other user selects that.
yeah.
They're encrypted. And then do they
The
get
inputs
decrypted, or do we compare the encrypted inputs?
So we can have both. If we want to show it in the front end, we would have to like decrypt the first user's input as well as the second user's input. But if you want to keep
Yeah,
like both them hidden, we can just do a comparison operation, just and get just the e
that's super
boolean whether
cool.
that you want or not. So we can
How long? This is FHG, right? To compare
uh,
these
no, this
encrypted
is
inputs.
um, yeah, I don't know. So yeah, we have references of FHE in our older documentation, which is why it keeps mentioning FHE. But yeah,
Okay,
um, we're not FHE as of yet.
as
But
in a
yeah,
T.
it's
Right.
yeah, right. So yeah, input zero is rock, paper is one, and scissors is two. And the way it gets draw is like zero and zero. So yeah, basic logic of rock paper scissors. And we do something called so for a draw we do an equivalence check, and we do a greater than equal and a lesser than equal check for the other moves. So that's yeah. So when a second user joins the game, right, he won't be able to see this. That is move one. Game.move one
Mhm.
is a encrypted type. It's a EU in 128. So if the user tries to see, hey, I want to see what the first user's move is and try to like cheat or something like that, he won't be able to do it. So that's the whole point of like shared state that they can manipulate, but they cannot see it. So as you can see, if you were to do this in a plain text world, you would have to have like an off-chain commitment of what the first move was, and basically do all this off-chain and then settle it on-chain. But here, play it on-chain. So that's the whole point. Now, let's go over what is happening here. When the user joins a game, we have to grant decrypt allowance of his own move. So joins the game. In the same transaction, we will allow him to view the ciphertext of his own move as well as the first player's move. So this way, like it's not like he cannot see it before the transaction, but once it's done, he'll be able to see the result, right? So that is about allowing the ciphertext, and finally we compute the result. So oh, this looks like a very huge logic, especially given there are so many links. So let's go over it. These are just initialization of plain text values to ciphertext values. And yeah, so e-select operations are where the branching condition is, right? So based on whether like, hey, if it was, so based on this logic, if it was like rock and rock, it's going to call a draw, or if it was rock and paper, P2 is supposed to win. So that logic is decided in e-select. So based on the equivalence check, you know, say like, hey, the player two is the winner, or player one is the winner, and then we write it to game.result, again an encrypted type.
Do you
Finally,
have any
we have
other encrypted UINTs except UINT 128?
we will be introducing 64, 128, so 64 and 32, and we will have encrypted bytes or encrypted byte array.
Nice.
But as of now, it's only those two types. But there are
Cool.
multiple operations you can do on top of it. You can probably like look into that. So we have additions, fraction, multiplications, remainder, and operations or operations, shift operations,
Mm.
greater than equal check, basically comparative, and yeah, with the we have ERAN. This will help when you're playing with when you want encrypted random numbers in your logic. So and we have ERAN bounded. So if it's within certain bounds that you want your encrypted number in. And finally, given all these are encrypted types, right? You will have to prove that, let's say you want to reveal some information on chain, saying, hey, this was in fact what I got. So if I won, right, I need to prove on chain that I won and I have to withdraw my sol. So that is where TEEs provide something called attested reveal. So I can probably go over that concept once. So yeah, what is attested reveal? So, well, yeah, the client basically he's going to ask for he's going to decrypt once like a certain allowance is given. He gets his attestation and a signature from the TEE saying, hey, this is the plain text for this handle and I attest that this is correct. So the trust assumption here is that the TEE is always correct and has the right decrypted value. Now the client builds a ED255 verification signature, which is where you will come across is valid signature. So what is valid signature is it we register the TEE's signing key during the initialization of the life cycle, and any attestation for the plain text and handle pair that this key sends is assumed that it's the correct value. It's not manipulated. So the client sends the attestation as well as the plain text value. That's when the executor program verifies that, hey, yes, this is the actual plain text for this encrypted value, and then you'll be able to do any logical like any logic that requires the plain text value of a ciphertext. So that is the whole point of is valid signature. Yeah. Now coming back. So once you join the game, you compute results using e-select for all of this. That's a lot of cross-program notation. So you basically like encrypt these plain text values that you need for the result, and then you compare and do the logical branching on top of that. And this is basically for allowance. So the way we do allowances is we create a zero data account for every allowance pair for every user to hand ciphertext. And what the co-validator does is it checks whether this account exists or not, and only then it will give you the ciphertext. If the account does not exist on chain, it does not allow you to view the ciphertext, which is why we send it in remaining accounts. There's a reason why we are sending it in remaining accounts. I'll be talking about that when I'm going over the tests. Let's write tests for this.
So I think remember at the start we were going to go 2 modes, multiplayer and single player with like encrypted randomness. Has it done both those modes?
I think it's just multiplayer long.
Okay, cool. We can probably just add. Yeah, I'm curious about the randomness stuff.
Yeah. So single player mode just uses ERAND and remainder, so it makes sure like it's within the bounds, and you'll be able to work with that. So basically, your guess is against the encrypted random number. It's like playing against a computer, right? So yeah, the whole game is pretty simple, but it's to cover as many concepts as we can.
Yeah, this is cool.
Yeah.
Seems relatively easy to work with.
Yeah, that's the whole point. We wanted to have it like so you're gonna have like anchor programs. You can work with Pinocchio, you can work with native Rust and still be able to build with it. You don't have to learn like different languages just to start working with encrypted types.
What's this working with? Is this Anchor? Yes.
Yeah, this is anchor. Yes.
Cool.
Yeah. Meanwhile, I will also talk about so what do I mean by other? Just a second. Access control. So there is a slightly different pattern as opposed to like what you do with your plain text transactions. As I said, this creates accounts every time you want to do an allowance, right? So a program creates a handle, so we just a handle, and it is stored in. Now, when you call allow, we derive a PDA from the handle as well as the address that needs to be allowed, which creates an account on chain. Now, what the T does is it checks whether this exists or not, and then it will like basically allow you to view the ciphertext. So when through the JS SDK, when you call attested reveal over here, so when you call decrypt with your address, so you will prove that I am the actual owner of this public key by sending a signature, and this is what happens in the background. It does a check and it returns you the ciphertext. So this requires one important pattern, that is simulation. So when you see here, right, like for example, maybe we can go to the token program, just because it's much easier to understand that. Yeah, here you will see that this has sufficient is a Boolean type. This handle, let's just go to the Boolean type. You'll see that it's a U128 handle, so it'll just be a number on chain. It is generated uh, on the go. So this handle is generated in runtime using a like specific algorithm. So we will not have an idea of what this handle is before I send this transaction. So for that what you but the thing is I want to allow the user to see his balance, right? I want him to be able to see his balance. But I do to allow that I need to have this handle available, which is why we do something called simulations. Why are we simulating? The handles that are generated are deterministic. So you will get the same handle for during the simulation as well as when you broadcast the transaction. So this way you'll be able to get the allowance PDA. So I told you, right, like you'll have to derive this PDA. So you'll be able to get that beforehand, and you'll be able to send it along with the transaction. That is why you use the remaining accounts to call allow. So this is an important pattern that you have to follow when you're developing with Inco, and I want to see if like we are able to do that with Claude. Oh, yeah, it seems to have added the single player approach as well. Let's just look at it. Yeah, random. So you'll see that it's doing a random number and setting it between 0 to 2. So this way, and adds one to it so that you get an offset between 0 or 1, 2. So it basically, yeah, it just random and the same select operations. Just yeah, the same select operations as we had for a multiplayer, and you will get the. So this is like when you're not playing against anyone. It's not multiplayer, but it's a single player. But the whole point of having encrypted type is like, what do you call it? It's redundant here. So because when you're playing this, it can be plain text random and it's happening in runtime. So even if the user knows what the value is, he can't try and change it. But in a multiplayer setting, he can do that. So this is just to understand like how erand works. So yeah, let's write test for it. Uh, Simulation patterns. You know what? I want to see if it does it on its own.
What what model are you using?
This is 4.6. Opus
Okay, nice.
4.6. Yeah. What do you use?
Yeah, usually Opus 4.6 or Claude. Or no, or Codex. Codex has been pretty
Yeah,
good for more logic
I agree. I
flows.
agree.
Yeah.
So, yeah, so you will see that like first you need to get the remaining account. You will have to get do the basically understand at which byte we have the handle at. So move one and move two is where the handles are at. So when you run the simulation, you will have to start from the 16th byte. So yeah, this is hard to understand when we are developing it on our own, but once like it's the agent doing it, we'll be like, hey, yeah, crazy, yeah, nice. Let's go to the tests.
Yeah, okay. Oh.
Oh, it's yet to write tests. Yeah. So far, like, do you have any doubts that you think I should address right now? Right. Yeah. So we have the tests here. Yeah. You'll see that, like, the helper functions which allows you to like get the allowance PDA. So this is so first you simulate the transaction to get the handle, and then you create the allowance PDA and dispatch the actual transaction.
Is it done them in
That's right.
Web3.js?
Yeah, it does use Web3.js and the Solana SDK that Inco has for encryption. So
Is the Solana SDK
Web3.js.
that Inco has compatible with only Web3.js?
Uh, we do not. Yeah, it is. So the only component from use is the attestations. So when you
Mm-hmm.
want to, right, you will have to prove that you are the signer. So for that, if you're player one has to prove that he is the signer when he's decrypting. Just give me a second. That's it.
Mm, okay.
So while decrypting, he will send his along with the handle that he wants to decrypt. So he signs a message using web and the handle that he wants. That's the only place that we're using Web3.js. So it's pretty compatible. So you'll be able to encrypt, and in attested decrypt, this is where you need to construct the ED25519 signature. So that is probably another component that we share with Web3.js. So yeah,
Right.
it is pretty compatible.
Okay, cool. I was asking because we have a new, well, not new, but we have a JavaScript library that's like, it's called Kit. I don't know if you know about this.
Yeah. So we are currently only on DevNet. We'll be soon launching a local net. You can just work with yeah, the like local validators. And yeah, it's much easier to develop with it. But we are doing it on DevNet because that's we don't have to like build Docker images that listens to the local events and stuff.
Cool.
Yeah, you need to have some balance on DevNet. So I have like some 13. So
Yeah.
yeah. No, let me just walk you through the test itself. Like, even I have no idea what test it has written. So,
Just blindly
mm,
run them. I love how we work with. No, I do the same thing. AI is just like, yep,
I mean, it's
why not?
smarter and it's referring the docs that I wrote, so it's obviously going to be
Oh,
correct.
it's trying to
Yeah.
run the airdrop, even though you have funds.
Oh, I see. That's because player two doesn't have funds. Let me just,
Right.
uh,
Ask it for the address and use the faucet.
yeah.
I got issues with that command as well.
We can, yeah. Yeah, so, geez. All right. You can, this has nothing, so you can, there's no point.
Our OPSEC is
You
high.
just
That's true.
want,
Yeah, faucet dot or faucet.solana.com.
I've not exhausted my faucet, but I do. Yeah, I'm definitely exhausted.
Cool.
Yeah.
You can do it twice. You can do another one so you can get like more salt.
Yeah, that's the thing. I've exhausted it.
Oh, right.
Never mind.
Did it work though? Does
Getting
it
back to
have
the
the
test.
2.5?
No, it doesn't. I'll
Send it to
probably like
me.
oh yeah. Where does I send it?
Just doing the restream chat.
Right.
Okay, cool.
There you go.
Okay, funds. Funds coming. Okay, check now. You should have 5.
Awesome. This is crazy. It just wrote to do the test.
Awesome.
Yeah. So I was talking about the. Oh, thank you. I do have 5 solana.
Welcome.
The simulation flow. I'm just trying to find it.
Yeah, it did a test that you can't join to play against yourself. That's a pretty good random
Yeah,
use case
so
to
you can give
test.
access to Bash, and it just does it on its own. Oh, it hasn't deployed the program and it's testing. It's like crazy. Ah,
Did it write these tests for the Inco token as well, or did they come with it?
I think it did not simulate a transaction.
Hmm.
Yeah, this is what I was talking about. Like it's gonna keep debugging for the entire day. I'm gonna be like, oh wow.
Interesting. Do you have this information in the MPC in the MCP
What about it?
server? Because it's not simulating, right?
Yeah, it is not simulating in this test, so I need to ask it to simulate before it sends. So yeah, the thing is, the transaction does not revert even if you don't send in the remaining accounts. But the problem is your transaction now is like it cannot be viewed. So the user that is participating in the transaction cannot view his balance anymore. So you need a separate transaction on your program to make sure that he is allowed to view his new ciphertext, which is not ideal. So we have to send it in remaining accounts. Geez. This seems to be some issue with the deployment.
Wait, what did it just say about 12 Sol?
I think that's because there are like certain buffer accounts that are created and not yet closed. Uh,
Oh,
yeah.
okay.
Yeah, I kind of expected this. So I have another program written out before. It's written out by Claude itself, but it was in its good behavior. So I'll probably work with
But
that. Yeah.
does this happen a lot? What exactly is the problem?
So when I use the same account to deploy multiple programs, right? So it opens buffer accounts which I have to close before I'm able to send more transactions. So it seems like it has deployed. So yeah, that's the only issue. Usually people use fresh accounts to deploy, but if you try to use the same account to redeploy, yeah, you get that.
Right.
All right. Um, well, one last thing is simulations. So this is why I encourage like using the DDK, because you'll be able to reference tests of that has been written already. So,
All right,
yep,
cool.
issue. Yeah, there's one failure, that is the handle mismatch. So handle mismatch happens when the simulation and the transaction is different, but yeah, I'm not sure why it's happening. Yeah, we also need to log the.
Okay, yeah. Now I figured out what to do.
Yeah, so we're able to test whether like paper against stock. So the multiplayer tests are much easier to do. So we check whether like, hey, are we getting a draw or not? So how are we checking that? Let's go to test itself. Yeah, we first join the game and wait. Yeah, we start the game first, and then we join the game with a rock as the input, and then wait a minute. Yeah, right. It is not logging the results. Let me just ensure that it logs the results. This assertion is pointless. Like, hey, what am I going to do with this? Yeah. All right, let's hear. Right. So you see this result handle. What is read handle? It gets the handle. It's hard to read test written by AI. I'm like, what am I doing here?
What is read handle?
Read handle sets the offset. So when you simulate a transaction or send a transaction, whatever is stored in the account, right? Like it basically reads at which position or which handle is it. So move one starts from byte 16. So it reads from
Oh,
byte
right, okay.
16 till yeah. So that is what it is.
That makes
Returns a
sense.
handle. Seems to be an issue over here. Decrypt handle as. It is only using decryption for the server game, but not the one uh, like with multiplayer. Oh, also, once it runs out of context window, it's gonna wait for like around 30 to 40 seconds just to like compact whatever chats we have, and it'll basically
Yeah.
just redo it. Yeah,
See what it
all over.
forgets. It's always funny when it compacts this conversation, then it's just like, oh, where are we? Where are we? What are we doing?
Yeah, and there are times when it starts like just appreciating itself, like, oh, that's a good
Yeah.
idea, we should do it.
Yeah, Opus does that. I haven't seen that with other models though. Opus loves to
Yeah.
tell itself that it's amazing. Maybe while we're waiting on our test, we can get Deepak in and do some front end stuff.
Yeah, that would be a good idea. Um, you know what? I can just walk you through the test that I had before this. Yeah, so simulate and read handle is the function that I'm trying to talk about. Oh, what it does is it simulates the transaction first, and we get the handle. So, with this handle, what we do is we derive the PDA. So our get allowance PDA takes an input of a handle and the address that needs to be allowed. And how we get this handle is through simulations. So we first simulate the transaction that you want to send and get the handle from it and create the PDA. So for the next transaction, right? Uh, we send it as a remaining accounts. Just a second. Yeah, here we send it as account. Where are the remaining accounts? Just a second. Yes, here. So you send values as remaining accounts. So this way, in our this thing, right, like RAM, when we want to do allowance, yeah, call allow from remaining accounts. Let's go to the definition. So what it does is it creates an allowance account based on the accounts that you just derived and sent. And when you query the co-validator, you will be able to get the plain text only if this function has gone through. So let's actually run these tests. Maybe. I forgot the command for this. Just, right. Yeah. You know what I'm gonna ask
Yeah,
Dr. Lewis?
that's what I'm just thinking.
Student definite man. After this, it's gonna ask me the key, the deployment key.
Hmm.
Yeah. Oh, never mind. Okay, yeah, it's doing it now. Yeah, see, I told you the wallet that I need to work with. Yeah.
Cool. I've got to get going in 30 minutes, so maybe it would be cool if we can jump to front end stuff.
Yeah, let's do it. Deepak, you can refer the repository that I've given you to build on top of it, or I can push the one that is already here.
All right.
Yeah, the tests are. So you'll be able to see your move as well as the CPU's move and the outcome of it. So we will take a look at the transaction itself. Um, So you'll see if you go to the logs, right? You'll see something called like as new event 28, and you will send a byte array of ciphertext. So this is basically an encrypted input that you create, and the operations are done on top of that. So the random input, that is the input that the CPU or like basically like, against the CPU, and for the comparison. So we need to keep it within the bounds. The remainder, the equivalence check, as well as the select, basically select. Yeah. So this allows you to basically decide who the winner is. So this allows you to branch between, hey, whether this is the right input. If so, if the boolean is true, yes, he's the winner. If not, he is not. So yeah, that is the entire flow for this program.
How's the other one doing?
Yeah, you want,
The original one that
sorry.
how's the original one that we were trying to
Oh
vibe
yeah,
code?
no, it's now. It has its own error. Let me see. Yeah, I can probably tell how it's doing once Deepak is done with his front end.
What was it doing?
It's trying to run the tests basically.
Okay.
Yeah, so it seems like it has added allowances.
Awesome.
Each time given it's on DevNet. So yeah, we'll have to wait. I think like Claude is really good for front end. So it generates even like the components that you wanna, like basically the what do you call it, logos and stuff. So it generates that as well. So the graphics and
Mm.
everything. So I'm interested in looking at that.
Should
We
we
are
get onto
staying
that?
forever to run the test. Yeah, I think we should talk about the front end now.
Cool. Hey Deepak, you're the front end guy, right?
Hey, yeah, I'll be looking into
Awesome.
front-end integrations.
Nice. I
Yeah,
think
yeah.
Sudeep, you've
This
got
test
this
in
pushed,
now.
right?
Oh no, seems like oh right, it has the incorrect format of handle. But yeah, I'll run this test again. But yeah, it needs to be sending it in hex format. All right, yeah. Do you want to start off, Deepak?
Yeah, sure. Is my screen visible?
Not yet.
Yeah, it's visible now.
Yeah.
All right. All right, let's bring our rock, paper, scissor private dApp to life. So let me just, so basically I just use Claude Code. That's it. I think it's enough for me.
Do you use the front end design skill?
Yeah, for design as well, pretty simpler designs. And actually, I just give the screenshots. I look for the design on browser, and then I just take a screenshot, snapshots, and like share it with it. So like it does pretty good job with that. Let's just create Next.js. All right, let's just name it front end maybe. All the recommended. All right. I'll call my intern.
So are you using Cursor as well, or is this VS Code with Claude?
No, VS Code integrated with Cloud Code.
Cool.
It's taking pretty time. Till that, let's get ready with our prompt. So it might seem pretty weird, but like I just talk with the agents like humans. So yeah, we'll start with hey. So hey, I want to build a UI for rock, paper, scissors, private tab on Solana. The programs for it are already implemented in the folder RPS game. I will. So I have taken a snapshot. I'll just copy it and share it with it.
What's the snapshot from?
I just randomly browsed and like took a Figma design snapshot
Okay.
for the rock paper scissors. Yeah, I've shared with you a screenshot of the UI. Make sure you make the hand movements back and forth like how it is in IRL RPS. Yeah, let's give it good context. Uh, let's, all right, yeah. Also, please implement Solana wallet adapter. So I've downloaded the official Solana dev kit, skill we have. All right, so I'll just tag it and yeah, I guess we are good to go.
Is this the Solana dev skill that you got from solana.com/skill?
Uh, no, there was a GitHub repo for it.
Okay, yeah, I think it's that one.
Yeah, yeah, it's that one. So it has the reference you made earlier, like with Sudeep, the framework kit, the Solana kit, instead of F3JS.
Yeah.
Yes.
Would that be
Yeah.
a problem with working with Inco?
Nope.
Okay.
So all right, it's going through entire code base. Packages and enter the plan mode. Oh yeah. Also, I was just want to mention that working with Inco's JSDK, please make sure you're using the right version, which is basically 0.0.2. So yeah, and our SDK is named as @Inco/Solana SDK. Pretty simple. Let's see what it's doing. Documents using Solana. Oh yeah, this test file would be pretty helpful.
The test file is in Web3.js though.
Let's see how it like figures it out or bring
Yeah.
it to some conclusion. Create game, join, play single player. Okay. Nice. It has like detected the image perfectly.
Do you have any tips for how to prompt? It doesn't seem like. Are you using the MCP for Inco?
Yeah, Inco's MCP is also there. Like,
Okay, the compressor. All right. Okay. Cool.
yeah.
Perfect. Do you have any tips for prompting front end in general or Inco front end?
Uh, like, yeah, be pretty precise what you wanna do. And yeah, in every prompt, like if you're like, let's say you wanna do 15 different things, maybe it may miss some. So
Mm.
you can do like 5 things properly first, then next 5, and then next 5. So that's pretty helpful. All right, it's letting the ideal. In the meanwhile, let's go through our JS SDK. So yeah, we have 3 pretty simple functions, which is encryptable and a decrypt. So in while encrypting a value via client side and then sending it to your Inco, like the Anchor program built using Inco Rust SDK, which is Lightning. So you just need to like import encrypt value function of from our Inco Solana SDK, and you can just encrypt value. So make sure our co-validator supports integers, begins, and booleans, not strings. So yeah, make sure you are using correct data types for encryption and sending it to your Anchor program. So attested reveal basically is decrypting the value but not posting the transaction on chain. So we'll basically just show the decrypted value on your UI. So decryption of the plaintext values. So it is a decrypt function which takes 2 params, wallet signer and sign message and address. So this is it. And in attested decrypt, you decrypt and you value on chain. So this is the pretty simpler difference between both of them. So these 3 are the functions in Inco.js SDK. All right, let's see what are. Let me just see the plans for now. All right, create ideal and program constants, create wallet adapter patterns. Looks cool, but let's just use Bun as a package manager.
Nice.
I prefer Bun.
Me too.
I feel it's much, yeah.
Yeah. I'm probably get acquired bun, so hopefully we won't have to keep prompting it anymore to keep using it.
Mm-hmm. Yeah. It happens a lot that like you think you have prompt everything, but in meanwhile,
Yeah.
yeah, you have lost pretty much things. So it's never one prompt.
That's true.
Alright, so it is just copy pasting all the get allowance PDA, allowance accounts, extracting handle from Little Indian format. Yeah, this is cool that we are using hooks separately.
Yeah.
I think it does pretty great job like keeping the code base modular and clean as well. So we're gonna have four types of components, basically our hands, rock, paper, scissors, movements, wallet adapter. Alright, so where basically we will yeah have a play for a single player function, create game function, join game. Alright. Oh, generate.
We're basically just one-shotting this,
I guess it has
trying to
hallucinated
get it all
here.
in one
It is
time.
not using encrypt value.
Hmm. Is it using other things within Inco?
Yeah, it is like just thinking that it is not production. So it is saying instead of the Solana SDK,
Oh,
we are just like encrypted move buffer.
it does
So
that quite
yeah.
a lot. Doing these marking stuff
Hmm.
and
Yeah,
yeah.
even though not instructed.
Yeah, it's interesting.
Let's see if it added Inco's SDK. Nope.
We will have to end the stream in 10 minutes, FYI. So it seems like it's getting to a point,
Yeah, we
a good
are.
point now. Is it actually using Kit?
There isn't any instance. Okay, Cloud Code is running the instance inside it. Let's just see what it has done. So
Damn. Looks
it
good.
has done a pretty dope job. Okay,
Oh, whoops.
all right. Let's just restart. Okay, it's still there. Mm, Let me just ask us to refer.
I wonder if our skill is using the right Inco version.
Oh, let me just try to build these programs. So that I can get a ideal to for a context.
Yeah, that makes a lot of sense.
I guess it was building the ideal on its own with the wrong formatting.
Yeah. Yeah, this is an issue I think quite often with building with AI is that it really struggles to whenever versions are updated. It does a lot of old things,
Yeah,
even in the when we were
and it has the older. Yeah,
yeah.
yeah, it still refers FSG as Incos. Yeah,
Yeah, exactly. Even though you're using the MCP, and I'm sure the MCP
keys.
doesn't say anything about FHE.
Yeah.
It's interesting trying to figure out how to fix that.
Okay, we do want test file as well, and integration. Oh, from all right, it got the path. Oh, it was a handcrafted.
Yeah, it does that.
Oh, I guess the adapter is working now. Adapter is working. Paste game key. Create game. Okay, this is single player. Account name
Let's
using
try it
source
with a
file
single
is well.
player.
Yeah. Oh, it's a draw.
The
Wow.
animation is
Let's
moving.
just ask it to transaction leaks on UI.
What's it gonna do?
Let me just copy my address and till then go to check Explorer. Oh yeah, it really made a transaction. Yeah, our single player thing is working fine. You can see the ciphertext handle being generated, new e-random. We are playing again open random.
Nice, that's really cool. There's nowhere we can
Yeah,
see early what this like. Nice.
yeah, let's just try. Yeah, okay. Yeah, pretty cool. Yeah.
Really cool.
All right, so
Nice one.
our DAP is, yeah, right. Yeah, similarly, we can do similar implementation for multiplayer as well for demo purpose. I guess this is pretty enough.
Yeah.
And hope you guys understand how to use Inco, MCPs, doc MCPs, Cloud Code, Cursor, whatever your favorite agents.
Yeah, that was pretty great. We built an entire rock, paper, scissors completely private game on Solana in like an hour and a half. So
Yeah,
nice.
More than have like much complex games. I think a lot of people who build for like the privacy hack, they build poker and stuff. So yeah, like given the right amount of time, we can build much more complex games.
Yeah. I
yeah,
like the DevX. The DevX is really intuitive. So I think even if you're building with AI, it's easy to go in and like debug it yourself.
Yeah, I agree. The only place that I thought like it'd be harder for devs to understand was the simulation pattern, but like based on the feedback that I got, I think yeah, people understood it pretty early. Yeah,
Yeah, I'd say so. Cool, this is
awesome.
awesome. Have you got this live anywhere where somebody could check out this repo?
Yeah, the repo is live. I think we can add the front end to it. Um,
Yeah, that'd be really cool.
yeah, where do I link it?
yeah, fine.
If you tweet it, and then let me know, I can retweet it from Solana Devs so people
Yeah,
can have a look at it.
sounds good. I will do that.
Perfect. Yeah, it's a
Awesome.
really good kind of beginner guide and like to feed it into Claude as well, for people to build their own stuff. Works very
I
well.
agree.
Nice. Awesome. Thanks, guys. Really appreciate you coming on.
Yeah,
That was super
Thank you so
informative.
much for having us. Bye bye.
Of course. Bye, guys.